we're going to start working with tangent segments. Now, the tangent segment is a segment that touches a circle at one point. For example, here number 15, just for us to see. Let me highlight this segment. You see, it touches the circle only at one point. Actually, the line will touch the circle one point. Now, a segment, I mean, come out with another segment here. This other one in green, it is not a tangent segment because if I was to extend it into a line, it will touch the circle more than once. So that's not it. The tangent segments are only those that are part of a line that touches the circle only once. Now, another interesting part of tangent segments is when you intersect a tangent segment and a radius. So the intersection of a tangent segment and a radius is always 90 degrees. So I see that the line JK is tangent. I see that PK is a radius. So I'm going to say this corner here is 90 degrees. And again, when a tangent segment touches a radius, they cross at 90 degrees. Cool. Let's see what this question says. JK, the line JK is tangent to circle P at point K. Find the measure of the angle JPK. So JPK is this angle, right? Let me call it X for right now. And we have to solve for it. Okay. Now, what I'm looking at here is I'm looking at a triangle. And I know two angles of the triangle. One of the angle is 65, the other angle is 90. The third angle is what I'm working with. But I remember back in the days, we used to say that if I add the three angles of a triangle, so X plus 65 plus 90, we learned that the three angles of a triangle always add up to 180. So I'm going to use that rule to solve for X. Let me separate them through the equal sign. On the left side, when it comes to letters, it's just 1x. Number-wise, 65 plus 90 is 155. So I have that x plus 155 is equal to 180. To get the x by itself, this plus 155, let me move it to the other side as a minus 155. So that means that x is equal to 25. Oh, that's it. I solved for x. Good to go. Now, let's take a look at question number 16. Angle C circumscribed about circle P. So that means that the angle C is outside of the circle, and then you guys see when it expands, it touches the circle from the outside. Find the measure of angle BPA. So angle BPA is this angle. One thing that I know, a couple of things that I know is that there's two 90-degree angles. You guys see that? There's two 90-degree angles. Why? Because the tangent segment, when the tangent line and a radius intersect, make a 90-degree angle. Now, what if you guys see, I'm looking at a four-sided figure. I'm looking at a quadrilateral. Now, all the quadrilaterals, all the figures that have four angles, they always add up to 360. So what I'm going to do to solve for x here, I'm going to add my four angles. So x plus 90 plus 90 plus 51. Which order do you write them all for? It really doesn't matter. I'm just writing all my four angles equals 360. Every quadrilateral, the angles of any quadrilateral add up to 360. guys might be wondering, why is that? Because look, a quadrilateral, if I was to cut it in half, it creates two triangles. If one triangle is 180, well, two triangles is 360. That's really why. Okay. Now here, let me solve this real quick. Uh, X by itself is right there. Now 90 plus 90 plus 51 is 231. So I have that X plus 231 is equal to 360. My plus 231, let me bring it over as a minus 231. So X is equal to 129. Just remember that when a tangent line or tangent segment, in this case, a tangent line and a radius cross, they make a 90-degree angle. That's why the corners A and B, I call them 90-degree angles because a tangent and a radius make a 90-degree angle. Okay, I was working up until number 18. So let's take a look at another interesting part of tangent segments. We're gonna looking at the perimeter. Now, a tangent segment, a circumscribed thing outside. So let's say here, I'm gonna be looking at a point here. Interesting part is that this two tangent segments, so two tangent segments that meet outside of the circle have the same length. Okay, so those two, whatever one of them equals, the other one is the same measurement. Two tangent segments that meet outside of the circle have the same length. So that means that this tangent segment is equal to this other one. And then that would tell us that I'm gonna go in green. This green tangent segment is equal to this other one. Well, what are these measurements? 18.5 is the whole side. I'm gonna use that later. 20 is the whole side, but 11 is only the green tangent segment. So if one of the green tangent segment is 11, I'm gonna say the other one is also 11 because I said they were all equal to. If the green tangent segment is 11 and I know the whole side here is 20, so 20 minus 11, I'm gonna say this red tangent segment is 9, right? Because 11 plus 9 is 20. So that means this other red one here is also 9. Now, if this whole thing right here is 18.5 and part of it is 9, I'm going to say this blue segment here it is 9.5. So that means this other one here it is 9.5 as well. Now, it says here, find the perimeter of each polygon. To find the perimeter, I know for perimeter I have to add all the sides. Assume the lines which appear to be tangent are actually tangent. When the perimeter of the triangle QRS, so this triangle here. Okay. So I know I just have to add all my numbers. So this side right here, I'm just going to call it 11 plus 9.5. Oops. Actually, I'm going to write it up down here instead. 11 plus 9.5 plus. Now this whole side right here, I'm just going to call it 18.5. And the third side down here, I'm just going to call it 20. So 11 plus 9.5 plus 18.5 plus 20. According to my calculator, I get 59. Let's take a look at number 18 here. All sides of triangle QRS are tangent to the circle P. RS has a length of 7. Okay, so that 7 is the whole thing here. Let me remember something. I'm going to color things out because actually that's going to help us out later. These two red segments here, these two, I'm going to call them red. I know one of them equals the other. I'm going to say this blue with this blue and this green with this green. And let me figure things out. Okay, so the segment RS, so a red and a blue equals 7. So remember, RS is this whole thing. UQ has a length of 10. Okay, so that means this other green one is also 10. Find the perimeter of triangle QRS. Okay, you might be wondering, I don't know these two. So far, what I know is if I add the two green ones, so 10 plus 10 plus the 7, which is this 7, right? This whole thing. I need to figure what those two that are highlighted. But think about it. Isn't the 7 on the left side made by a red and a blue tangent? So can I say that these two combined, I don't know how big is each of them. I don't know how big is the red. I don't know how big is the blue. But can I say each of them? Like I said, I don't know how much each of them are, but if I combine them, isn't that another 7? Because remember, how did we get the 7 on the left? By combining a red and a blue. So here I have to combine the red and the blue. So wouldn't that be 7 as well? Okay. So in this case, 10 plus 10 plus 7 plus 7 gives me 34.